Number 36, integral from 1 to infinity, ln x times cosine x over x squared plus 1 dx. This is improper because the upper limit's infinite. We don't have a domain restriction here, or we technically do. Ln x has to be greater than, or x has to be greater than 0, which it is in our limit, so we're okay there. Okay, no domain restrictions in this particular case. Just this upper limit's infinite. Okay, this is actually very similar to number 29 if you saw that video, okay? Why is it similar? Well, it's because I'm going to be comparing with the same function, okay? But let's go through the comparison, okay? We know that cosine of x, the range is between -1 and 1. So let's just start with x squared over x squared plus 1. So no ln x, not yet. Okay, we're starting here. This is less than or equal to 1 over x squared plus 1. As I just explained, the range of cosine is upper bounded by 1. Okay, now just multiply ln x on both sides. Okay. So there's that aspect. I should have written one more step, but pretend there's a plus 1 here first, okay? But this is also less than or equal to ln x of x squared, because if it's x squared plus 1, that's even smaller, okay? Or you can just think of it from here now. Let's just look from here. 1 plus x squared versus x squared. We're dividing by more on this side, okay? That makes it smaller in that aspect. And then the top, the cosine, is what I explained earlier, okay? It's upper bounded by 1, okay? So this is the function to compare with now. I'm choosing to compare with. And this is the exact same as before. I probably just copy paste. This is integration by parts, so I'm not going to go over that. The limit is 1. Since this guy converges, and our guy is even smaller than this, pretend it's an improper integral, or right here, I guess. Our guy's going to converge as well by comparison test. So honestly, the hard part is deciding the function to compare with. And this is how one example of a function that works.